So the first thing that we are going to learn in data normalization is what actually is data normalization. So data normalization is defined as a feature scaling method used to scale numerical feature in a dataset to a common range, typically between 0 and 1. So here we learned about two new things, feature scaling and numerical features. So features, what we call in our data the columns, same thing is termed as features in a data set when we are talking about machine learning, and this data normalization is an integral part of machine learning. And feature scaling, we will study about it later. So normalization has the following benefits, which are: it allows machine learning algorithm to treat all features equally, it prevents numerical instability issues, it improves model performance and convergence speed, it enables fair comparison between features with vastly different scales. Feature scaling, let us learn what feature scaling is. So feature scaling is a technique to normalize numerical feature in a data set to a common scale. So everywhere we are getting this word scale. So what is the scale? Suppose in our data set we have 3 columns, and in each of the column the values are in different ranges. Suppose in first column the values are in millions, in the next column the values are in hundreds, and in the other column the values are in thousands and 10,000s. So we are having 4 different scale. If we are going to feed this to our machine learning algorithm, so the algorithm is going to assign more weightage to the feature that is in higher scale. So in order to bring all the data in same scale, we use feature scaling. And in case of data visualization, suppose we are going to visualize the 3 features on the same data. Suppose we are going to visualize the 3 feature on the same graph. So the variations in the data, where the data is in range of hundreds, is going to be almost lost in comparison to the data that is in 10,000s and millions. So this is the reason we also normalize our data or scale our data for visualization purposes. And the importance of feature scaling is same as that of normalization, because normalization is a form of feature scaling. In addition to normalization, standardization is another feature scaling technique, but here we are not going to deal with standardization, we are only going to deal with normalization. So what are the few common techniques of normalization? So here is a list. First of all, we have min-max scaling. So the min-max scaling, this method or this technique brings the data within a fixed range, that is from 0 to 1. So the formula to normalize our data using the min-max scaling is as follows. It is x minus x min divided by x max minus x min. After that we have robust scaling, normalization using median and IQR, and this method is non-susceptible to outliers. Suppose we are having outliers in our data set and we want to normalize it. In that case, robust scaling is better suited for the work. And in this, the formula is x minus x median divided by IQR, also known as interquartile range, which is also derived by the formula 75th percentile minus 25th percentile. Then we have mean normalization, and this is utilized when we want a centered data around 0. Therefore, it is also known as mean centering. And the values we get through mean normalization is between -1 and 1. and the formula is x minus x mean divided by x max minus x min. After that we have max absolute scaling, and this scaling method is better suited for the data that is sparse, meaning it has many zeros in it, and the formula is x divided by absolute of x max. So these are the four methods of data normalization. Now let us go and study min-max normalization technique in detail, because we are going to be using this method to normalize our data. So the min-max scaling is a technique used to normalize numerical feature in a dataset to a common scale, typically between 0 and 1. And the formula for min-max scaling is x scaled. So this x scaled is the new column that we are going to get after we have successfully normalized our feature. So x scaled is equal to x minus x mean divided by x max minus x min. So now we learned about the min-max scaling method and about how to normalize our data using this method. But what actually happens with the data, let us understand that graphically. So suppose we have this spread of data, and here we can clearly see that our data is spread from 0 to 1 on the x-axis and 0 to 2.5 on the y-axis. Now we will be normalizing it with min-max scaling, and after that what's gonna happen, let's see. We have the same spread of data. The distance between each data point is also the same. Nothing changed. No underlying information is lost. No data point is lost. Everything is same. The only difference is that our data has been squeezed together between the range of 0 to 1 on x-axis as well as 0 to 1 on the y-axis. So this is actually what happens in min-max scaling. Now that was an introduction to min-max scaling and normalization of data. Now let us go to Excel and see how it is done in Excel. So here is our global superstore data set, and from this data set we wish to plot a graph between total sales that we are going to derive from the multiplication of unit price and quantity, profit and quantity. Okay, and check as to which product is performing better. So first of all we are going to insert a new column and call it revenue, and this will be a multiple of these two. Now this is created. Now we are going to insert a pivot table and summarize our data on the basis of product name. So first of all we will select the entire data set and turn it into a table. Then we'll come to insert pivot table and make sure that we are inserting the pivot table on the table that we created, and we insert the pivot table on a new worksheet and click on OK. Now I will bring in, suppose category I want to bring in, or let's bring subcategory, and then we want quantity, unit price and revenue. We want to plot all these. So see, this quantity is being presented as a sum. We'll come to the value field setting and then we will go to currency. And how do we want to summarize the unit price? Let's take average. In the sum of revenue, just currency. Okay. Now see, all these numbers are on different scale. These These numbers are in the scale of hundreds, these in the thousands, and these in the 10,000s and 100,000s. So we can no doubt plot a line chart or whatever we want on this. We are going to plot a line chart, but let me plot the chart first. See, the biggest value, that is the sum of revenue, is clearly showing us all the variations, but this average of unit price and sum of quantity, they are so small in comparison to this sum of revenue number that this variation is just flattened out. So what can we do in this case? So these are some of the cases where a normalized data set gives us a better result. So in order to normalize our data, we are first going to bring all this summarized data out of the pivot table. And the process is fairly simple. Just click on a cell, type equal to, and give the cell reference and press enter. Similarly, we'll bring all the other datas. Okay, this is done. Now we need to know three values about our data points, and that is min, max, and the difference between min and max. So here let us write min, max, min minus max. Here we will type equal to min in this range. We got it. And then, so the formula for normalization is x minus x min divided by x max minus x min. So let us put in the formula. This is our x minus this is x min, and we want this to be fixed for entire calculation, divided by x max minus min, this is the difference, divided by this, and this will also be fixed. Okay. Similarly, we are going to normalize our rest of the columns. And this is our normalized data. And now we are going to create a chart on this normalized data, and let us see the difference. See, so these are the two charts. Let's take them to a separate sheet. See, now have a look at these two charts, and we can clearly see that this chart shows the variation between sum of quantity, average unit price, and revenue very well. and from that we can say that chair has a comparatively lesser unit price, but the revenues coming from chair is better, and also it is being sold in a lesser quantity, whereas this binder being sold in a lot of quantities, but the revenue and the unit price is very low. And this is how we normalize our data set in Excel, and this is the benefit of normalizing our data before we create a comparative chart among them.